Good day, everyone. My name is Carlson Pinsha, your candidate number 7. Today, I'm going to discuss the mathematics and 19th century. The 19th century saw an unprecedented increase in the breadth and complexity of mathematical concepts. Both France and Germany were caught up the age of revolution which swept Europe in the late 18th century, but the two countries treated mathematics quite differently. After the French Revolution, Napoleon emphasized the practical usefulness of mathematics, and his reforms and military ambitions gave French mathematics a big boost, as exemplified by the three L's: Lagrange, Laplace, and Legrand. During this time, mathematical ideas became more complex and advanced. Both France and Germany were uh, heavily influenced by political revolutions, but they handled mathematics differently. So after the French Revolution, Napoleon believed that mathematics was essential for engineering, military strategy, and national progresses. Because of this mindset, he supported mathematicians and strengthened math education. This period gave rise to some of the greatest mathematicians like Lagrange, Laplace, and Legrand, often called the three L's. They helped shape modern calculus, mathematical physics, and the foundation of many subjects we study today. Now we have Évariste Galois, a French mathematician famous for his contributions to the part of higher algebra now known as the group theory and Galois theory. He proposed that there is no general algebraic method for solving polynomial equations of any degree greater than 4. Galois was a French mathematician who worked on problems related to solving polynomial equations. His greatest achievement was proving that there is no general algebraic formula for equations of degree 5 or higher. He created what we now call the group theory and the Galois theory, which are used today in fields like cryptography, coding theory, and modern algebra. Even though he died at only 20 years old, his notebooks and ideas completely transformed mathematics. His contributions show us that age does not limit genius. Next is Joseph Fourier, known as the Fourier series, made contributions to meaning of a function like domain and range, and study infinite sums like trigonometric function. So Fourier was a French mathematician and physicist who deepened the understanding of what a function truly is, especially in terms of its domain and range. He is famous for the Fourier series, which allows us to break complicated waves or signals into simple sine and cosine functions. This become important in physics, heat transfer, sound engineering, and even digital technology. Thanks to Fourier, many modern systems like audio processing, communications, and computer graphics work the way they do today. Next is Jean-Robert Argand, a French-Swiss mathematician who composed Argand diagram. He published his papers on how complex numbers of the form a plus b1, where a is square root of negative 1 could be represented on geometric diagrams and manipulated using trigonometric and vectors. So Argand was a French-Swiss mathematician known for introducing the Argand diagram. This Argand diagram shows complex numbers written as a plus bi on a plane where the x-axis represents the real part and the y-axis represents the imaginary part. His work helped people visualize and understand complex numbers more easily, especially when adding, subtracting, or graphing them. Argand's diagram is still useful today in engineering, electronics, and mathematics. Next is George Boole, an English or England mathematician, philosopher, and logician. He was best known as the author of The Laws of Thought, 1854. He was also the founder of Boolean algebra or Boolean logic and Boolean operators. So Boole was an English or England mathematician, philosopher, and logician who wrote a book called The Laws of Thought. And he also introduced what we call today Boolean algebra. One of the famous major works of Boole was the Boolean algebra. Can be used to compare and manipulate sets using the three operators and, or, and not. He also used Boolean algebra, which used two objects on and off, or true or false, and 0 and 1, and etc., in which famously 1 plus 1 equals 1. So these diagrams helps us understand logical relationships between sets and represents the overlap or intersection of sets, or represents the union or combined area of sets. Not represents everything outside the indicated set. These diagrams make it easier to reason logically and see how statements or sets relate to each other. Venn diagrams are widely used in probability, logic, data science, and everyday decision making. And also, Boolean algebra is the foundation of computer logic. It uses only two values like true or false, yes or no, and 1 or 0. This is also the reason why in Boolean mathematics 1 plus 1 equals 1. Because our logic means that if at least one value is true, the reason is true. Almost every device, which computer chips, cell phones, laptops, and even calculators, use Boolean logic. Boolean's work truly shaped the digital world. So this is an illustration of the Boolean algebra using Venn diagram. First, the diagram is AND, which means overlap or intersection. The second diagram is OR, which means combine or union. The last diagram is NOT, which means everything outside the indicated set. Next is Charles Babbage, an English or England mathematician, engineer, and inventor, who was condemned the father of computing for his detailed plans for mechanical calculating engines. He also created an early model of calculator that used card or tape. So Babbage was an English or England mathematician, engineer, and inventor, also known as the father of computing. He was the first person to conceptualize a mechanical machine that could compute automatically. In 1822, he designed the difference engine, which could perform mathematical calculations. Later, he improved this idea with the analytical engine, which had features similar to a modern computer, such as memory output and input. Although these machines were never completed during his lifetime, his designs inspired the invention of real computers. Without Babbage, the computer science might not exist today. So these are the two mechanical calculators Babbage created. First is the difference engine from 1822, and the second is the analytical engine from 1830. Next is George Peacock, an English or England mathematician. He published the book titled Treatise on Algebra during 1830. He also credited with the invention of symbolic algebra. So Peacock was an English or England mathematician known for his work in developing symbolic algebra. Before Peacock, algebra was mostly used just to solve equations, but he formalized the rules and symbols we now use in algebraic expressions. His book Treatise on Algebra, published in 1830, helped shape modern algebra by separating arithmetic operations from symbolic manipulation. Peacock made algebra more flexible and abstract, opening the door to more advanced branches of math. And the final one is John Venn, an English or England mathematician who introduced Venn diagram, which becomes useful and ubiquitous tools in set theory. It is also introduced in 1880. So Venn was an English or England mathematician and also the creator of the Venn diagram, and is introduced in 1880. His diagrams become extremely useful tools for representing sets, logic, and relationship value visually. Venn diagrams are now used in schools, research, statistics, computer science, and even problem solving. They help us analyze similarities, differences, and interactions between groups or ideas. My report ends here, and thank you for listening.